In the first lesson we have seen an introduction to Arduino, and we have understood that in my application Arduino receives both analog and digital signals. Those signals are then processed by Arduino in order to take decisions and to send digital signals to the outputs in order to do things like, for example, increase the volume through the motorized volume control or show information on the display. In the second lesson we went a little more in deep with the Arduino programming, and we analyzed one by one the possible signal inputs to Arduino. We have seen some examples of outputs from Arduino. For example, we have seen how Arduino can drive the displays. We have seen the relevant programming as well. Let's now complete the scenario. So let's still speak about output signals from Arduino. Digital output signals from Arduino are utilized to select the audio input within the amplifier. I have 4 different options, and here you can see the relevant code. So the chosen audio input is selected by energizing the relevant relay. This is done by putting the relevant digital output pin within Arduino in high logic state. The same exact solution is utilized to allow the user to switch between FM stereo and FM mono. We have this small black relay within the FM tuner's stereo decoder module you see here. And again, in order for the user to switch between stereo and mono, Arduino operates on this relay by putting the digital output pin in low or high state. Finally, exactly the same is done in order for the user to switch between optical and coaxial inputs within the digital to analog converter module. Again, also in this case we have this small relay you see here, and again Arduino drives this relay as soon as the user select one of the 2 inputs within the DAC module through the remote control or the encoder. As a last topic covered in this third and last lesson, let's just mention one possibility made available by Arduino. In order to get some energy saving and to reduce any noise induced by Arduino to the audio circuitry, it's possible to put Arduino in idle mode. Idle mode is one of the, I would say, energy-saving modes made available by Arduino. When Arduino is in idle mode, the microprocessor is stopped. So in this way we can achieve energy saving. But all the digital output pins state remains exactly the same as before. This is very useful because every selection the user made previously, I mean before Arduino went to idle mode, is kept, is saved. So I utilized this very useful feature in order to put Arduino in idle mode, standby mode, after 30 seconds since the last action by the user. In this way, for example, if the user selects another input, another audio input, for example, switches from FM tuner to Bluetooth input, then after 30 seconds Arduino goes to idle mode, thus saving energy and avoiding to induce noise to the audio circuitry. And here you can see the code. Interrupts can wake up Arduino from the idle state. So, as you remember from the last lessons, interrupts are triggered when the rotary encoder is rotated or pressed, or as soon as a button is pressed on the remote control. So if any of those said actions are done by the users, Arduino wakes up from the idle mode. That's all for these 3 lessons on Arduino. I hope you found them interesting, and stay tuned for the next projects. Thank you very much.